The stakes are high when using AI for investment decisions like sentiment analysis on financial news. I'll start with the foundation model, but I'll fine-tune it so it has context from recent world events and uses proprietary data for an investing edge. We've created an integrated experience that empowers everyone to use the same powerful tools OpenAI and the tech giants use. I'm going to show you how Domino makes fine-tuning foundation models as easy as running AutoML. Domino Code Assist is our Jupyter plugin that generates code to accelerate productivity for common data science tasks like data access, transformation, and visualization. Now it can generate code to access and fine-tune foundation models. There are 3 simple steps. First, you need to choose a foundation model from a list based on common tasks. It's easy to make an informed choice with all the details you need readily available. I'm going to use Finbert, a foundation model for sentiment analysis on financial news. Finbert was trained on 4.9 billion tokens of corporate reports, earnings call transcripts, and analyst reports. However, I'm going to fine-tune it with additional data collected over the past few months from industries I'm focused on to ensure it performs optimally for my needs. By clicking Fine-Tune, I can perform the second necessary step to choose my data. Domino Code Assists make it easy to find and select your data and connect to it and map it to the inputs required for the fine-tuning job. Third, I can click Run. This will insert the code, which is great because it's transparent and modifiable, not a black box. It also facilitates collaboration between different types of talent on your team. The less technical folks can start work that the more expert data scientists can review or refine. And I did all this without leaving my workspace. While this is running, notice that Code Assist even generated the code necessary to log key experiment metrics and track them using our new experiment manager powered by MLflow. This makes it easy directly from the notebook to be able to track how well the experiment is going. Let's take a look. Experiment Manager enables automatically logging key metrics and artifacts during model training to monitor the progress of AI experiments, including model training and fine-tuning. You can also compare different runs to select the best model. And unlike the open source MLflow, we've even added enterprise security to ensure only approved personnel are allowed to see metrics, logs, and artifacts. As you drill into a specific run, you can see that Experiment Manager is tightly integrated with Domino's reproducibility engine to automatically track the full lineage of which version of your code, data, tools, environment, and more. The full set of materials you need to reproduce experiment results. As we drill into the details further, we can see that my experiment did okay, but not great. To improve my model's performance, I'm going to try hyperparameter tuning. Code Assist also generates the code necessary to automate the hyperparameter tuning. Powered by the latest innovations in open source, Domino has integrated Ray with built-in native optimizations for large language models to automatically scale out, on demand, and get done in hours what otherwise may have taken weeks. This tuning task is going to run a lot of jobs in parallel. To save time and money, I'm going to run this in my on-premise NVIDIA GPU cluster, which always has the capacity I need and is much cheaper. Domino is the only platform that supports orchestrating workloads across hybrid multi-cloud infrastructure. I'm going to configure this on-premise cluster to use the right number of machines for the job, leveraging my on-premise DGX SuperPod the most efficiently possible. And because the metrics are streamed back to the experiment manager from the on-prem GPUs, Domino provides a single pane of glass to monitor experiments regardless of whether they're running on-premise or in any cloud. We can see now we have a significantly better performing model.